A very good evening to all present here. I welcome you AICT sponsored ATAL-FDP organized by Mechanical Engineering Department, S&T College of Engineering and Research Center, Yeola. It is my pleasure to introduce our distinguished speaker for today's session, Dr. Pradeep M. Solanki, sir, an experienced academician and administrator in the field of mechanical engineering. Dr. Solanki, sir, is currently serving as an associate professor in the Department of Mechanical Engineering at SSBT's College of Engineering and Technology, Bambori, Jalgaon, and also as the Training and Placement Officer of the Institute. He has 18 years of expertise in teaching, research, and administration with a strong record of academic leadership and student mentoring. He holds a PhD in mechanical engineering from KBC North Maharashtra University, Jalgaon, ME in CAD/CAM from Ram Meghe Institute of Technology and Research, Baldnera, Amravati, and B in Production Engineering from SSBT's COET, Bamburi, Jalgaon. Dr. Salunki sir is also recognized PhD guide in mechanical engineering and Board of Studies member for mechanical production and automobile engineering at KBC NMU, Jalgaon. He has published 26 research papers in international journals, successfully handled funded projects, and actively contributed to STTPs, FDPs, and workshops. Dr. Solanki has also been invited as a resource person, judge, and jury member at several state and national level technical events, demonstrating his versatility and commitment to the profession. With his rich experience and contributions to engineering education, Dr. Pradeep Solanki sir is well placed to share valuable insights in today's session. So, on behalf of our institute, I request all the participants kindly join me in extending a very warm welcome to Dr. Pradeep Solanki sir. Welcome you, sir.
Thank you. Can I proceed the session?
Yes, sir.
My slide is visible.
Yes, sir.
Yes. And my voice is audible.
Yes, sir. You are audible.
Yes. Yes. Thank you very much. Very good evening to all. First, hearty welcome to all the participants in the 1 week ATAL-FDP, which is organized by the Mechanical Engineering Department of the S&T College of Engineering and Technology, Evla. My today's topic of presentation is the PLC system and its integration in the Industries 4.0. Here it is the brief about a brief file of myself. Then here it is the contents of my today's presentations. Means a few of the points related to the PLC systems and some of the superiority of the PLC systems over the hardware systems. Industrial revolutions, history of the industrial revolutions, and key trends in India. The PLC, as we know that the PLC was invented in the response to the needs of the American automotive industry. And before the PLC, some of the operations like controlling, sequencing, safety interlock logics for the manufacturing automobiles was accomplished using the relays, timers, and dedicated closed-loop controllers. In 1968, the General Motors Hadromatics issue a request proposal for an electronics replacement for the hardwired relay systems. And for updating the such facilities, yearly model changeover was very time consuming and expensive. And as the relay systems needed to rewired by the skilled electronics. And hence,
Sir, your voice is not audible. You are muted. Sir, please kindly unmute yourself.
yes.
Yeah, thank you, sir.
And the bed associated started the new company and the new product, Modicon. That Modicon, which stood for the modular digital controllers. And the persons which work on the project was the D.K. Morley, and it considered as the father of the PLC. And then this Modicon brand was sold out in 1977 to the Gold Electronics and later acquired by the German company AEG and then by the Schindler's Electricals, the current owner of the PLC. Then the National Electrical Manufacturer Associations defined the PLC in a different manner. And the PLC is the programmable memory for the internal storage of the instructions for implementing the specific functions such as the logics, sequencings, timings, countings, arithmetics to controls. All the such types of operations can be performed by the digital operating electronics apparatus and through the digital analog input output modules. The various types of the machines and processes also operated by these digital operating electronics apparatus, it named as the PLC. And here it is the same. This industrial digital computer specially designed to control the manufacturing processes, machineries, automation systems. And the features of the PLC are it is reliable, capable of withstanding the harsh industrial environments such as dust, high temperatures, humidity, and electrical noise. Due to these features of this PLC, it is most popularly used in the various industries. Then the overview of the PLC. The PLC has multiple input terminals where the signals from the sensors, switches, and other devices are connected. And these are the states based on the voltage level received. The scan these inputs to detect the changes in a machines or processes. Then based on the input states, it executes the programmable logics and generates the corresponding outputs. Also, the PLC has the output terminals also. And the output terminals which send the signals to the external devices. And these signals are either high or low. And depending on the control logics executed by the PLC, the outputs can directly operate the device. And that device such as the motors, indicator lights, and relays, contractors, etc. And by switching these devices on and off, the PLC is able to control the industrial processes. And in short, in the efforts to make the PLC easy to program, their programming language was designed to resemble ladder logic diagrams. And due to these ladder logic diagrams, the electricians and engineers familiar with the traditional wiring diagrams can easily understand and program PLC using these methods. Hence, the ladder logic diagrams plays an important role. Just a minute. Video. Then see, here it is the two images or pictures. And in traditional control system, all the devices such as, if you see, there are two in the traditional systems, all the devices such as switches, relays, and motors are wired directly to the output devices to perform the specific functions. And this creates the complex wiring problem that are hard to modify or troubleshoot. And any changes in the control logic requires physical rewiring of the systems. But on the other diagrams, or on the other hand, right diagrams, here, all the sensors, switches, and control devices which work as the input, which are directly connected to the PLC instead of to each others. And the PLC processes the inputs, executes the input, executes the logic, execute the program logics, and then it sends to the output devices. Due to which what happens, this reduces the complex wiring and make the systems easier to modify, expand, and troubleshoot. Here so is the simple difference between the traditional systems and the systems uses the PLC to control the devices are wired to the PLC. Then some of the key features of the PLC. As we know that the PLC must be the programmables, means the logic can be designed easily without altering the hardwires. Due to this ruggedness design to withstand vibrations, temperature fluctuations, and industrial noise, the PLC it withstand with all these obstacles. Then the main feature of the PLC is the real-time operations. It executes the control task in the milliseconds. modularity, it can be expanded with the input and output modules. And mainly the important is the communication. It is integrate with the other softwares, means SCADA, HMI, then sensors and actuators. And all the PLC possesses all these features, and due to these features, it is popular in the industry sectors. Then, as we know that the basic components of the PLC, basically the PLC, it consists of the 5 important components, in which first is the input module, and the input module is responsible for interacting with the machines and the instructors, which can be external sensors, switches, etc. Then this part of the input module take the inputs and send to the processor or the CPU to respond accordingly. Then second component is the output module. Output device is responsible for interacting with the endpoints external device like motors, solenoid valves, contactors, alarms, etc. And it converts the control signals to the control signals from the PLC that this device can interpret. Then here is the power supply is one of the components, and PLC requires the stable power supply to run its program and match the voltage levels that need for the PLC components. And the main important components of this system is the programming device. As the PLC mainly a programmable device, and so we need a device where we can write a code and execute it. Here, in this way, these are the basic components due to which the PLC plays an important role. Then on classifications of the PLC, means the types of the PLC. Here the PLC, it is classified on the basis of the inputs and output terminals. Again, one more classifications, it is based on the hardware setups. It is based on the power supplies. And again, this number of input and output terminals, the PLC, it is named as the nano PLC, micro PLC, medium PLC, then large PLC and very large PLC. And based on the hardware setups, it is compared compact PLC, modular PLC, and rack PLC. And based on the power supply, it is the with SMPS PLC or without SMPS PLC. And this compact or PLC, in the compact PLC are the small size. If you see in the next, here, it is the compact PLC. The compact PLC are small in size. Means if you see the input output capacity of the compact PLC, it is nearly about the up to the 320 points, and other is the 180 points. And here, due to this small size, it is limited number of input and output points. And in this compact PLC, the critical factor is the space, and the control requirements are relatively simple. And these compact PLC are oftenly used in the small scale control applications, where the number of devices to be controlled and monitored is limited. But on the first one is the modular PLC. In the modular PLC, we see the input and output capacity up to the 2560 points. And it is designed with the modular architectures. And the specialty of this modular PLC is that where the CPU, then power supply, then input output modules are separate components. Means for each components we are giving the separate modular sections. And this modular design provides the flexibility in the system's configurations, making it easier to expand or modify the systems based on the changing requirements. Third one is the rack PLC. In the rack PLC, this is the type of high-end PLC Because if you see the input capacity up to the 5,120 points, as compared to both the tools, compact PLC and modular PLC, rack PLC is the high-end PLC, which is specially designed for the complex and demanding applications. Then is the main is the superiority of the PLC over the hardwired systems. And here, just a minute, one must superiority of the PLC over the hardware systems, in which it eliminates the much of the hard wiring that was associated with the conventional relay control circuits. As we know that before the PLC, we are using the relay control circuits. And that relay control circuits is replaced by the PLC, means it eliminates the much of the hard wiring which is used in the relay control circuits. Here it is the first superiority of the PLC over the hardware systems. And then this hardware system, it is replaced by using the program, take the place of much of external wiring that would be required for the control of the processes. Here it is the first point. Then this first point is defined with the help of this example. Let us say the two push button is there, PB1 and PB2. Both the push buttons PB1 and PB2 are connected to the PLC, and the two pilot lights PL1 and PL2 are also connected to the PLC. See, then how it is working? There are these two devices connected. Now pressing the push button PB1 means when you are pressing the push button PB1, the pilot lights PL1 activates. Then when you are pressing the PB2, then pilot light 2 is activated. But if you want to change this in such a way that when you are pressing the PB1, control the PL2. And when you are pressing the PB2, controls the PL1. But in the traditional system, if you are using the traditional systems, you would have to rewire the circuits so that the wiring from the first push button PB1 goes to the second PL2 and vice versa. But instead of these traditional systems, if you are using the PLC system, in that case, if you want to make the changes, means if you want to operate the press the PB1 and activate the PL2, and if you want to operate the PB2 and activate the PL1, in that case, if you are using the PLC, that you have to make the simple change in the control programs. Once you have to make the changes in the control programs, there is no need to make the complications of the wiring. Here is the superiority of the PLC it reduces the hard wiring options. The next is the second reliability point is the reliability. PLC provides the higher reliability than the hardware relay logic because the programs are digital, transferable, and error-free, and it ensuring the consistent performance across the machines. Means how you can say that it increase the reliability. See, once a program has been written and tested, it can be downloaded to the other PLC. And since all the logic is contained in the PLC memory, there is no change of making a logic wiring errors. Here it is the one ladder logic diagrams. In this ladder logic diagrams, at the input sides, there is L1 is the input signals. Here it is the L1 is the inputs at these sides. L1 is the input signals and connected to the limit switch S1. And this signal is read by the PLC. And in the ladder logic diagrams here, the timer of delay is used, a block is used, and the preset value preset time is set to the 5 seconds. And the logic decides when the outputs, means here it is the output terminals. And this logic decides when the output terminals or outputs, means M1, M2, G and R, it gets on and off. And here the PLC drives the outputs M1, M2, G and R. For examples, M1, M2 tends to the motors, then G for the lights, means it's a green light, R for the red lights, for examples. In this way, due to these functions, you can say that the PLC increase the reliability. Then next is the flexibility. In this flexibility, if you talk about the more flexibility of the PLC, the original equipment manufacturer can easily provide the system updates for the process for the industrial process by sending the new program updates. Okay, instead of physically changing the hardware. And the PLC controls the process. Means here, if you see the one examples of the wood cutter machines, and in these wood cutter machines, here it is the one rotary encoders. The rotary encoders generate the pulses as the wood moves forward, and these pulses are sent to the PLC. Then the PLC plays an important role, or PLC executes the program logic and it sends the control signals to the cutter control. Then the cutter control to cut the wood at the right positions. Means here it shows the flexibility of the PLC, and it is easier to create or change a program in the PLC than the wire. Means as per your requirement or as per your need, you can make the simple changes into the PLC programs instead of we have to make the changes in the wirings and rewire the circuits. So hence, the end users can modify the programs in the fields. In this way, here is it's represent the flexibility of the PLC. Then next is the cost. And here the cost is original PLC were designed to replace the relay control logics. As we know that before the PLC we were using all the relay control logics, and the relay control logics can be changed by the PLC, and the cost saving is so significant. The coil is there, then springs, then armatures, movable contacts, fixed contacts. It means here it is the simple applications of the relay control logics. And here in this applications, here due to this electric power, the coil is get energized, and due to this in electric supply to the coils, the magnetic field is developed, and due to the magnetic fields, the armature is attracted toward the due to this magnetic field, it is works toward the fixed contacts. Then generally, if an application requires more than about 6 control relays, then it will be usually be less expensive to install the PLC. Hence, you can say that the PLC is the lower cost. Then communications capability. In the communication capability, they can be networked to perform such a functions such as the supervisory controls, then data gathering, monitoring devices, then process parameters, downloading and uploading the programs. All the such types of activity you can perform through the networkings. Means you can say that the PLC can communicate with the other control or computer equipments through via the networks. That is one of the superiority of the PLC. Then one more is the faster response times. As we know that the PLC operate in the real-time environment, which means that even taking place in the field will result in an operations or output taking place. Participants, please mute yourself. Participant Vijay. Mr. Vijay.
Participants are requested to please kindly mute.
Hello. Hello. Rani sir,
Yes, sir. Sorry for disturbance.
anyone please give me the reply? My voice is audible?
Yes, yes, audible, sir, audible.
Yes, yes, thank you. Here is the faster response times. In this faster response times, here it is the one simple examples in these machines that process the thousands of atoms per seconds, and the objects that spends only the fractions of seconds in front of the sensors. It requires the PLC to quick response capability. And PLC operate, as you know that the PLC operates in the real time, which means that the event taking place in the field will result in that operations or output taking place. Here it is the one more features of the PLC. It is easier to troubleshoot. PLC have the resident diagnostic features, means it likes the fault indicators, error codes, or output status lights. And this makes it easy for the technicians to quickly identify whether the problem is in the software or the problem in the wiring or the problem in the hardware device. The control programs means the ladder logics, then function blocks, etc. can be monitored in real times. And the PLC makes troubleshooting easy because you can see what happenings inside the programs in the real times. And they show whether the signal is on or off. It helps to associate whether the fault is in program or in the wiring or the devices. And due to which this reduces the downtime and it saves the maintenance cost. Hence, you can say that the PLC is easier to troubleshoot. Here it is the one more image. Then move to the our point up to these slides. Previous slides we are just talking about the what is the PLC and what are the components and how the PLC is superior than the relay logic diagrams. Then our next part of the today's presentation is the industrial revolutions, means the, as we know that there are industrial revolutions 1.0, 2.0, 3.0 and 4.0. Just overlook about the these industrial revolutions. The first industrial revolutions, that is industry 1.0, it is began in the late 18th of century and earlier 19th of century in the period of 1760 to 1840. and it highlights the major technological advancements that transform manuals and agriculture's economics into the machinized industrial economics. And if you see, all these are the key features here. All these are the key features of the Industry 1.0. Just see one by one in a short. The invention of the steam engines means in the 1769, the James Watt invented the steam engine in the first industrial revolutions. And it is considered the driving force of the first industrial revolutions. It also the reliable source for the power of the factories, minings and transports. And the second features is the steam power and the mechanizations. In the industry 1.0, the human and the animal labor was also replaced by the steam power machines. Due to which what happens, it increased the productivity and efficiency of the work. The features is the machinized textile industries. Invention like the spinning jenny and the power looms. Spinning jenny and power looms. It is revolutionized by the cloth productions. Due to these features, the cloth production is increased high. The large textile factories enlarge, replacing all manual workshops. Then here it is the some of the development in the iron and steel industries also. Uh, because the iron and steel becomes the essential for the machines, tools, railway tracks, and other infrastructures. And at the same time, it improved the transformations. Due to these features, the impact of the Industry 1.0 is shift from hand production to the machine productions. The growth factories and the urbanizations. And third is the impact the industry. The next is the second industrial revolutions. This second industrial revolutions, it is begins with the in the period of 1870 to 1964. And here in these second industrial revolutions, all these are the four features, or you can say that the uh, characteristics of the Industry 4.0, in which the first is the electricity as a new power source. Yes, before the electricity, industries mainly relied on the steam power, means the power from the coal, but allowing the factories to run machines more efficiently and safely compared to the steam engine, making it possible to locate the factories, yes, away from the water sources. Hence, the overall electricity becomes the backbone of the modern industry and urban development. Second point in the Industry 2.0 is the development of the assembly line. In the 1930, Henry Ford was developed the assembly lines, and it developed the assembly line in the Ford's Highland Park plant. And the key idea is instead of worker moving around to perform the task, the product move along the conveyor belt. Means in that case, the worker is stay at one position, but the product moves around the workers along the conveyor belts. Here it is the second revolution in the Industry 2.0. Then the next is the advances in the steel, chemical, and petroleum industries. These industries fueled the industrial expansions and shaped the modern economics. Here it is the third point. And the fourth is the growth of the telegraphs, telephones, and IC engines. Here, Due to this growth of the telegraphs, you can say that in 1830s to 40, it enables the long distance communications almost instantly, and it revolutionized the trades, bankings, journalisms, and diplomacy. The next is the, if you are talking about the IC engines, in the late 19th century, it is powered by the gasoline or the diesels, but it was more efficient than the steam engine used in the automobiles and later in airplanes also. Then the impact of the industry 2.0 is the mass productions and economics of the scales. It rises of the consumer goods industries and global trade expansions. Then after the industry 2.0, the next is the industry third revolution is the industry 3.0. It is the mid of the 20th century period is 1960 onwards. And in the industry 3.0, the first is the introductions of the electronics, computers, and informations technology. The starting, the industries began adopting the electronics for the controlling machines and processes. Then transistors are also used, microchips are also used. It is the revolutionary electronics, making the device smaller, faster, and more reliable. The invention of the computer is allowed industries to process the vast amounts of data quickly. Then, if you are consider the second point in the automations of the production using the programmable logic controls. As you know that before the PLC were using the relay logic controls, and these relay logic controls at that time it is hardwire relays and timers which were costly and difficult to modify. And here, as you know that the D.K. Morley, which is the father of the PLC, which they invented the PLC in 1969, and it make the PLC make the possible to automate the repetitive manufacturing task. For the automatic repetitive manufacturing task, it is possible only because of the PLC. Then control machines with the programmable software instead of the complex wiring. Third point is this automations of the production using the PLC is the factory become more efficient, reliable, and adaptive, leading to the third in the industry 3.0. One more third evaluation is the development of the telecommunications and satellites. The telecommunications advance from the landline telephones to the digital communications systems. Right now, we are on using the digital communication systems in the 20th century. Means here, its impact is the companies could coordinate the productions and trade globally, escalating the globalizations. And one more highlight, I want to highlight the one point is the use of nuclear energy as an alternative power source. As we know that after the World War II, nuclear science was developed in 1945. Not only for the defense purpose, but it is also for the peaceful use. Nuclear reactors, you can say that the nuclear reactors were built to generate the large amount of electricity without depending on the coal or oil. And some of the countries like the USA, the France, Japan invested heavily in the nuclear power plants in the year, or can say that the impact of the industry 3.0, it increased the efficiency and precision in the manufacturing. That is the most powerful impact of the industry 3.0. Then the next is the rise of the digital economy. Third one is the shift from purely mechanical systems to the digital automations. In this way, then the industry 3.0, again, it is further moved toward the fourth point is the fourth industrial revolutions. It is started in the 21st century. Present period is 2010 onwards, means right now ongoing. These are the three features of this industry 4.0, in which first is the cyber physical systems integrating the digital and physical worlds. Just a minute. Here, cyber physical systems means it is the such types of systems where the physical process means machines, sensors, or devices are tightly integrated with the digital computing networking. And such types of systems means physical systems are integrated with the digital computing and networking. Then it is such types of systems is known as the cyber physical systems. Then how it works? Cyber physical systems, how it works? See, as we know that the sensors collect the data from the physical environment. Once the data is collected, then data is analyzed in the real time using the digital tools. And after the data is analyzed in the digital tools means the digital tools is nothing but the softwares, then clouds, then artificial intelligence. The system is automatically adjusts the machines, process, and the operations. If you think some of the examples related to these cyber physical systems, integrating digital and physical worlds, as we know that the one best example I want to highlight is the autonomous vehicle. Everyone familiar with these autonomous vehicles? In that autonomous vehicles, adjusting the speed and the direction based on the real-time road data. There is no interference of the drivers. It's all the speed and direction, it is based on the real-time data. It is the best example of the cyber physical systems integrating the digital and physical worlds. Second examples I want to highlight is the smart grids adjusting the electric supply and demands dynamically. And third example, the remote health monitoring devices is the IoT enabled. That is the first point. So first feature of the industry or highlight of the industry 4.0. The second point, artificial intelligence means then IoT, then robotics, then 3D printings, cloud computing, big data, then augmented reality, then virtual reality. Here it is the some of the revolutionary technologies they are used in the industry 4.0. Just see, as you know that the artificial intelligence enables the machines to think and make the decisions. By using this AI, you can use in the predictive maintenance also, defect detection also predicted by the artificial intelligence. Second point is the IoT, networks of interconnected devices exchanging the data. Means for example, the smart sensor in the factories track the temperature data, vibration, and through the robotics. Advanced robots perform the repetitive tasks, complex tasks, or you can say that it works in the hazardous environments also. The next is the 3D printings. In the 3D printings, it builds the object layer it builds the object layer by layer using the digital design, means it uses the CAD models in the form of STL file. And next is the cloud computing. In the cloud computings, the on-demand computings, the power and storage over the internets. If you can use the storage through the cloud computings. Then there is the one word is the big data. The big data and analytics is the industrialist or industries analyze the massive data sets to find the patterns. And on the previous data or patterns, they optimize the process and predict the outcomes. Here it is the beauty of the industry 4.0. Then some of the points is the augmented reality and the virtual reality. Here the augmented reality or virtual reality, as you know that the augmented reality overlays the digital informations on the real world object. And the virtual reality is the create the impressive simulations. Here, and the impact of this point is the together this technology enables the automations, personalizations, and the real-time decision making in the industries. The third point is the smart factories and intelligent power chains. The example of the smart machines halts productions when the detecting a fault and signals maintenance stop via the mobile app. Here is the example of the smart factory. One example of the intelligent supply chains means the tracking the goods with the RFID chips from the factory to consumers, means due to through this RFID chips you can track the goods from the factory layout to the customer aid. Here it is some of the examples of the smart factories and intelligent supply chain. And due to which what happens, it's increase the efficiency, flexibility, and sustainability, and its ability to produce the customized products on the demands. Here is the three features or revolutions in the industry 4.0. The next is this pictures indicate the pyramids of the heart of the industry 4.0 is the smart factory, where we are using the both the devices. One is the PLC and second one is the HMI, means human machine interface. And each layers, this pyramid, it is divided into the three layers. If you see, here it is the layer 1, layer 2, here it is the layer 1, layer 2, and layer 3. Means bottom layer, then top layer, and middle layer and top layer. And each layer has the specific set of functions and functionality. Means the communication between these layers is facilitated via the various networks and protocols. Just see what is the contents in the layer wise. The first layer is the bottom layer of the factory floors. In the bottom layer, where this layer, it contains the sensors, actuators, switches, motors, and machines. All these are the input devices. Okay, and all these are the input devices. It is the part of the bottom layer, and these devices provide the real-time data. Real-time data means you can consider as the temperature, pressure, flow, and execute the physical actions. But all the things means the sensors is connected to the PLC via the communications, means the input output modules. The communication way is the input output module, means communication protocols link the peripheral devices, sensors, barcode readers, etc. through the canvas, then RS485 connectors, then Modbus, Ethernet to the transfer signals. By using these peripherals, it creates the communications protocols. Then important thing is that of this bottom layer is the without this layer the PLC has no input to process and no way to act on the real world. It forms the eyes and hands of the smart factory. Here it is about the first layer is the bottom layer. Just see, the next is the middle layer, or you can say that the control layer of the PLC. In the middle layer, if you see here, it is the use of the both the devices. One is the PLC and second one is the HMI, means human machine interface. As you know that the PLC receives the informations from the sensors and it's executes the programmable logics and generates the output. On the other hand, human machine interface HMI, it allows the operator to visualize, monitor, and control the process in the real time. And all these things communicated to the other devices via internet, then USB, Modbus, by using the various communication devices available to connect these HMI and PLC with the other devices. Then what is the importance of this layer? The importance of this layer is ensures the automations, monitoring, and the operator interactions. It reduces the wiring complexity compared to the traditional systems. Here it is the middle part of the PLC systems. Then top layer. In the top layer, it is means the management systems, means the SCADA and the business management systems. In this top layer, means here the data is shared with the manufacturing execution systems, manage the production scheduling, and the quality and resource tracking. Means here it is the MES, means manufacturing execution systems, and that it updates the manufacturing staffs and systems what units to be manufactured based on the customer orders. And this MES coordinates all the front end and back end factory logistics to all the orders. MES also enables the automized monitoring without the human iterations. The importance of this top layer is to transform the data into the intelligence for the smart decision making. And these layers make the flexibility, efficiency, and competitiveness in the modern smart market. In this way, these layers plays an important role in the modern smart factories. Then the main point is the integration of the PLC systems in the Industry 4.0, where traditionally the PLC were used to control the machinery and the processes based on the predefined logics. Then in the Industry 4.0, now the PLC were expected something from the PLC. Means the PLC are now expected to, first point is to collect the data, analyze the data, and share the data with the other automation systems. Second point is to communicate with the cloud platforms for the predict analytics and real-time monitorings. Third is the adapt dynamically to change the production's demands and systems behavior. And fourth point is to enhance the flexibility by integrating with the artificial intelligence and the Internet of Things. All these are the expectations from the PLC in the Industry 4.0. Then again, the point is the key trends in the PLC. In the key trends in the PLC and Industry 4.0 integrations. See, number of key trends available in the integration of this PLC and Industry 4.0. The industrial IoT and smart connectivity. This industrial IoT enables the PLC to connect with the sensors. If you see, here it is the number of communications, means the PLC is connected with the sensors, then actuators, then industrial networks, facilitating the real-time data exchange and intelligent decision making. Then same again questions, okay, how it works. It works means the as usual the PLC collects the real-time data from the environment, and or you can say that the PLC collects the real-time data from the IoT based sensors on the machines. Again, that data is analyzed in the cloud or locally using the edge computing. Here it the cloud services from that, and automated adjustment means are based on the system's behavior, improving the efficiency. The best example I want to highlight is the smart factory is the best example. And that smart factory is integrated with the IoT PLC to monitor the temperatures, pressures, and on the or mobile app, reducing the unexpected breakdowns. Here it is the one example of the smart factory. Key trends in the PLC is the cloud servers, due to which edge computings we are getting the some of the benefits, means you can faster response times. It reduces the latency of the real-time decision. Second benefit is the reduce the bandwidth usage, less reliance on the cloud ability. And here is I'm here to put the one examples. In that example, see the automotive assembly plant, edge computing enables the PLC to detect the quality defects in the real time using AI-powered vision systems, allowing for immediate corrections before fault parts proceed further in the productions. And here, due to these AI-powered vision systems, it can detect the fault in the parts before the proceed further in the productions. Here is the one is the beauty of the key features is the edge computing, which is helpful for the faster decision making. Then third feature, just I want to brief artificial intelligence and machine learning in the PLC systems. Here the PLC are evolving to incorporate the artificial intelligence and machine learning algorithms for the self-optimizations. Then again, how AI enhance the PLC? Then the AI-powered PLC learn from the historical data to predict the failure before they happens. Second is the machine learning algorithms. The machine learning algorithms optimize the energy consumptions based on the usage pattern. Means on the basis of previous data patterns, the machine learning algorithms optimize the energy consumptions. And third is the AI-driven analytics. It improves the process efficiency by identifying the bottlenecks and the inefficiencies. In this way, the AI and machine learning also helps in a lot of in the PLC systems. Then fourth point is the cloud computing and remote monitoring. In this cloud computing and remote monitoring means here the integration of the PLC with the cloud platforms, which allows the remote monitoring and control of operations from anywhere. Means with the help of this cloud computing, you can assess the centralized data for the real-time machine monitoring. By using this cloud computing, you can predict the maintenance alerts to prevent the breakdowns. And third point is the historical data analysis for the workflow optimizations. Here it is the one simple examples I want to highlight is the renewable energy company connects the PLC controlling wind turbine to the cloud-based monitoring system. Is here in this example, you see there is a renewable energy companies means it is wind turbines to monitoring systems. If the wind speed, just see, if the wind speed exceed the safe limits, then what is the role of PLC? In that case, the PLC adjusts the turbine angle for the optimal power generations while preventing the damage. The next is the next point, cyber security enhancement in the smart PLC. As the PLC become more interconnected, cyber security threats also increase, no doubt. But to add the industry 4.0 PLC and encryption is possible, but ensures the secure communications. Second is the user authentication and access controls. It prevents the unauthorized the system's access. And third one is the firmware integrity checks. It protects against the malware attacks. Here it is the cyber security enhancement in the smart PLC. Yes. The next point is the futures. Near about I'm finishing my presentations. The future of the PLC in the industry 4.0. Looking ahead, the PLC will continue to evolve the more intelligence, connectivity, flexibility, and the future trends. It include the AI-powered autonomous PLC that self-optimize the industrial process. Then second future of the PLC in the industry 4.0 is the seamless 5G connectivity for ultra-fast data transmissions, more wireless PLC for the flexible industrial setups, and fourth future perspective is the integration with the augmented reality AR and the digital twins for the enhanced the maintenance and simulations. All these are the future trends in the of PLC in the industry 4.0. Here it is the last. I'm acknowledged to the first of all, I express my sincere thanks to the coordinator, Dr. Harjit, Head of Department of Mechanical Engineering, and Dr. Harshal Rane is the co-convener of the FDP. And I also sincerely acknowledge to all the authors, researchers, institutions, and online and offline resources that I have referred to while preparing these presentations. And express my special thanks to the participants for your listening patience. Thank you very much for your listening patience to all the participants. Thank you.
Okay, thank you, sir. So the platform is yours, audience. You may have, if you have any queries, questions, you can ask. So I appeal the active participants, please have some interaction with our expert speaker.
Sir, what is AR?
Sorry.
What is
Here is the
AR?
augmented reality.
Yes.
Here is the augmented reality.
What is the future of AR?
Here the augmented
what the-
reality. Hello.
means it is means it is the recent trends. Hello.
Yes. Yes. Augmented reality is the overlay the digital informations on the real world objects.
Uh-huh.
Yes, sir. Any other participant interested to ask the question? Okay, sir. I think there is no questions from the audience end. So, good evening, everyone. So, it's a truly
Okay, thank you
privilege to
very much.
listen. Yeah, yes, sir. So, it's truly a privilege to listen to Dr. Pradeep Solanki, sir. Today, he has guided through his fascinating words on the PLC system. What made this session stand out, not just like a technical depth, but having a good connect with the large journey of industrial evolution. So, sir has explained about the industries, the mechanization from industry 1 to industry 4. So that perspective help us to see what is the PLC, which is not just an isolated system, but it's a integral part of how the industry continues to evolve. So, sir, your clarity throughout the way you wove the practical sites and conceptual understandings, and your ability to link the history of this PLC and the future of automation that kept the entire session engaged. And throughout the provoking session, we are having a good knowledge. Hope the audience is having uh, got the knowledge about this industrial evolution. So we deeply value the time and energy that we invested in the interaction. Sessions like the session is just like a long-lasting impact that inspires us for thinking differently and to prepare ourselves for the demand of modern engineering. So, on the behalf of S&T College of Engineering or the audience and AICTE-ATAL, we thank you once again for sharing your expertise and visionary uh, aspect. So, thank you so much, sir. Now, I request all the audience
Thank you very
to
much.
stay. Yes, sir. So, I request all the audience to stay connected. We will start our second session sharp at 7:30 p.m. Thank you so much. Thank you, sir.
अगर ये वीडियो आपके पास 7 सितंबर
Start. Hello. 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 Am I audible?
Yes, sir.
Okay. A very good evening to all present here. And I'm Dr. Rani. Welcomes you on ATAL-FDP program organized by Department of Mechanical Engineering, SND College of Engineering and Research Center Eola, sponsored with AICT New Delhi. It's my pleasure to introduce our respected speaker for today's session, Dr. Avinash Bagul, an accomplished engineer and researcher in the field of mechanical engineering. Dr. Bagul had completed his degree, Bachelor of Engineering in 2012 from Pillai Institute of Information Technology, and later on he completed his post-graduation from KBC North Maharashtra University, Jalgaon. As after post-graduation, he had awarded a PhD degree from Bhagwan University, Ajmer. Now he has a rich, diverse experience, having served as a head of Department of Mechanical Engineering at College of Engineering and Technology, North Maharashtra Knowledge City, Jalgaon, as a associate professor and PhD supervisor at Gangamai College of Engineering, Nagaon. He had worked as a industrial consultant for WPS Nippon, Japan, on ANSYS-based simulation projects. Currently, he is working as an assistant manager for design and technical R&D department at Star Coolers and Condensers Private Limited, Jalgaon, where he leads design, analysis, and product development of advanced cooling and refrigeration systems. Dr. Bagul is highly skilled in ANSYS static, thermal, compressed fluid dynamics, and design models, and has published multiple international research papers in reputed journals. He has also executed innovative projects on heat treatments of cutting tools, vibration analysis of gearbox components, and design of submersible pumps, condensers, and freezers. With his extensive blend of academic, industrial, and research expertise, Dr. Avinash Bagul is well positioned to share valuable insights in today's session. So, on behalf of our institute, I request all participants kindly join me in extending a very warm welcome to Dr. Avinash Bagul. Sir?
Thank you, sir.
Yes, sir. The screen is yours now.
Uh, is it visible, sir?
Yes, sir.
Okay, sir. So thank you for giving me this opportunity for the 1 week faculty development program sponsored by AICT under the AICT Training and Learning, which is ATAL Academic Initiatives. My session is the 8th session, which is on the interface, robots, and PLC. As we learn about the robots from last 2 to 3 days in this session. So I am going to explain you the one kind of robotics, which is the interface robotics. In this, in robots, an interface is any point or system that allows to interaction, communication, or connection between the robots and something else, whether it is a human operator, another robot, or an external environment. We can operate the robot from the IoT base also, as a previous session we had told about that. We can we can operate the robot from the internet or by wireless communication and all. So here you can see the basic robotics interface programming. Just like here, you can program the robot according to the coordinates. Here, you can operate the robot by using a tablet or using a HMI. And this is the latest version. You can see you can operate the robot by using a, sorry, my screen is slightly, hmm. Last you can see there is a brain computer interface. Yes, here the man seated and wearing the helmet, which gives the pulse or the signals to these robots, and the robot behave accordingly. So the importance of interface robots in the modern technology. Interface robots are also known as the human robot interface or human machine interface, are absolutely pivotal in the modern technology. They are the bridge between the human intentions and robotic executions, transforming complex systems into intuitive and usable tools. Then why interface robots are crucial today? Because the seamless human robots communication. Interface robots enable the natural interactions through the speech, gestures, touch screens, or even a brain computing, what we see in the earlier slide. This makes a robot accessible to non-expert. This makes the robots accessible to the non-expert, expanding their usability. This allows us who don't know about the robotics or any kind of the microcontroller, which helps to guide the robot. Uh, this interface allow us to communicate with the robot and give the command to the robots. Then second point is enhance productivity and automation. In industry and logistics, setting HMI allows the operator to monitor route, robot status, configure the task, and analyze the data in the real time. This this boosts the efficiency, reduces downtime, and improves the decision making. Then third, safety and reliability. Safety and reliability. Advanced interface includes the safety protocol that prevents the accidental and ensures the smooth operation in the collaborative environment, especially important in the healthcare, manufacturing, and autonomous vehicle. Then fourth point is personal and adaptability, personalization and adaptability. Robot can learn from the user preference and adapt their behavior accordingly, improving user satisfaction and task performance. Uh, think of the smart assistant that tailors response based on your habit. Then multidisciplinary integration. HRI combines AI, cognitive science, engineering, and psychology to create the system that understand and respond to the human needs. This makes them essential in fields like education, therapy, and elder care. So now we can see here the different types of interface robots. The interface robots comes in a variety types, and you can all means the industry wants to tailor made their robots as per their use. So there are some kind of the robots. You can see here the industrial robots, which are the pneumatic type, means those are operating on the pneumatics as well as hydraulics, using a servo motors, stepper motors, and all as per their precisions and their work. These robots works individually. They don't require the human interactions. If you assign the robots the task, they are going to perform that task without any interference of the human. They especially work in the sequential positions. Hmm. These industrial robots used in the manufacturing and assembly lines often includes the robotic arms and sensor for the precision task. Interface system allows the human operator to program, monitor, and control them safely and efficiently. Then second type is a collaborative type, which is a cobots. They are designed to work alongside with the humans in shared space, equipped with the safety sensors and intuitive interface like touchscreens and voice commands. Common in the factories, labs, and small businesses. These mainly these robots are stationary. You have to bring some items that you have to workpiece in the industries, work as a workpiece, and you have to manufacture in a precise way. Then these robots are used to help. You can see in the pictures, this man helping robot to grab the workpiece which is placed on the table. Then third is the medical robot. Uh, Everybody thinks that the cobots and medical robots both having a human interaction. Then why these medical robots are different? Because these robots are specially designed for the surgery. These robots allows the haptic feedback mechanism, which we can see the later. That's why this is a different robotic system. Medical robot assists in the surgery, diagnosing and rehabilitation interface, including the haptic feedback system, imaging tools, and remote control panels. Precision and reliability is the key, especially in the robotic surgery. Then third interface robots is the next interface robots are used in the military and defense robots. You can see the robot which detonating that dead bomb. These kind of robots used in the military, where the non-explode bombs they have to defuse or they have to blast. This kind of robot helps without losing any human's life. Mm. These robots are used for interface, are rugged and often remote controlled, even in a real-time with the real-time feedback. These robots are also used in the hazardous environment and also in a landmine place where the landmines are fitted underground. Then education robots. Education robot helps students to learn coding, sorry, then robotics and STEM concept. Interface are designed to be user friendly and often using a visual programming language and gaming fields control. You can see that kid playing with that robot. That this uh, interface is a here you can see there is a touch screen. The cameras are inside that robot's eye, and also mics were fitted. Those are the point where the human can interact with the robots. Then next is autonomous robots. Uh, these robots are specially used in the warehouses or where or cars. Their work is to transport their goods from one place to another place. This operates independently using AI and sensor data. Interface focus on the monitoring and override capability, often often through the mobile apps and dashboards. Each type of the robots is designed to make human robots collaboration smoother, safer, and more reproductive. If you want to explore some robots, you can go any website or the YouTube channel where all these kinds of robots you can see, or otherwise you can going to be see on the tomorrow's session, which is the application of robots. Then types of interaction interface. There are the several types of interface with the robots. I am taking some important one, which is the first is a graphical user interface. Means you have to program the robot by using or giving the coordinate where they have to work and which kind of the arm they want to move. In a graphical user interface, visual interface like dashboard, touchscreens, and computer displays are used for programming, monitoring, and control the robots. Common in the industrial, common is in the industrial robots and consumer devices where they have to perform the continuous operation. Then voice assistance. You can see there is a small robot. Hmm. This is the emo robot, which is useful for the playing or to do the wireless communication to our home automation devices. This is the home friendly or residential robot where you can tell him to switch on the light, switch off the light, switch on the fan, and all, and it gives the response and act accordingly. So the voice interface enables the interaction through the speech recognition and synthesis found in several robots, smart assistants, and healthcare robots, supports hands-free and control and accessibility. Then gesture-based interface. In the gesture-based interface, you can see the man having a belt on his arm, and that belt senses the muscles motion. What the that arm is making the motion, the robot mimics that motion accordingly. This kind of the mechanism generally used in the labs or where the hazardous chemicals is going to be used or the weight the man have to lift, but it's not able, it's about beyond the man's capability. Then what I told you about the haptic interface. Hmm. Haptic interface provides the feedback while working with the robots. Means if the man or the doctor operating that robot, it senses the feels, means the touch, the sensitive parts, uh, which robot touches, that feedback gives to the feedback is brought by the robot and send it to the doctors where they are operating that robot, like a pressure, vibrations, because in that system, when if doctor is doing a brain surgery, there are the critical parts where small pricking can leads to the death. So that's why the haptic feedback is important in the medical robots. Haptic feedback provides a to the crucial in surgery robots like a remote manipulation and training simulator. Hmm. Allows user to feel what the robot is doing. Next is a text-based simulation. So text-based interface. You can see there is a text written here, the script. Hmm. First is the loop for the 5 times, then then move again for the waypoint second. These coordinates are defined already for like a waypoint 1, waypoint 2, waypoint 3, and they have to perform their work just like a loop, something, and movement, and etc. This kind of the interface is known as the text-based interface. The command line and scripts are written in the that interactions used by the developers and engineers for precise control and debugging. Then a sensor-based interface. You can see there are the flat robots. Actually, these robots are useful for the car parking. uh, these robots are capable to lift the car and make that car move to the doorstep. These kinds of the robots are using the radar sensors, then communication with each other, then collision protection, then the load carrying capacity, load cells, and all. That's why these robot called as a sensor-based interface robot. Sensor-based interface, sensor-based interface that responds to the environmental input like pressure, temperature, positions, proximity. This is used in adaptive robot that react according to the surrounding. Then this one is the multiple interface robot. This kind of a robot works on the different kind of the interface like what we see in the last slide, and also like brain computer interface what we see in the first slide. Then brain computer interface directs the communication between the brain and robot via EEG signals. St- this brain computing interface is in a experimental stage. This is not completely developed, and this technology having some limits. Also, there is a remote interface where the programmer can control the robots from the wired or wireless communication. So you can see here the robot also rely on the communication protocols for the data exchange, which is a wire RS-232, RS-485, Ethernet, IP, CAN bus, and wireless protocols like Wi-Fi, Bluetooth, ZigBee 5G. These protocols ensures real-time responsiveness, scalability, and interoperability across the robot system. Each interface type serves a unique purpose, or many robots combine the multiple interface to create the seamless user experience. Then we are going to see what are the core technologies behind the interface. So there is a AI technology, which is currently booming the market, the artificial intelligence and machine learning that enables the robots to understand the language recognition of patterns and adapt to user behavior. Then powers the decision making, personalization, and predictive responses. Using the natural language processing, face recognition, and autonomous navigation. Then second technology is the human machine interface, where the touch screens, interfaces, and gesture controls allows intuitive communication. Then brain computer interface and emerging for the direct neural control in the associative robotics. Anyone from you know about the Neuralink, which is Elon Musk talking about? Okay, I think we should move forward. Neuralink is a robot that Elon Musk is going to be placed in the human's brain, which is connected to your brain by some sort of the wire, and the chip is open to the sky, so that it can be able to connect using a Wi-Fi connections and all. So if you want to contact with the machine, you don't have to gesture or something. Your brain pulse directly goes to the brain signals directly goes to the machine. That what Neuralinks wa- want to do, and they perform the one surgery, test surgery, and which is a successful by Elon Musk. robotic control systems, the real-time control algorithms manage movement, balance, and task executions. Includes the motion planning, feedback loops, and error correction for precision and safety. Then the one of the core technology is embedded system and microcontrollers. Compact computing units that process the sensors data and execution command ensures the low latency response and energy efficient operation. Then this is the human robot interactions. Human robot interactions is a dynamic field that explores how humans and robots communicate, collaborate, and coexist. It is not just about the program machine, it is about the designing the relationship between people and intelligence system. The key component of the HRI is a precision system. For that, we use the cameras, microphones, and sensor to detect the human nature or human face readings or human behavior. Then interface design, which uses the graphical user interface, voice command, gestures, and other feedback system. Then behavior modeling, which predicts the and adapts the human actions, which is good or which is bad as per the human behavior. Then the ethical framework, which is the important in the robotic environment because it ensures the safety and privacy and the trust between the user and the machine. Hello.
Yes, sir.
So I thought my display is
Yeah, your screen is not shared.
there
Please
is some
share it.
problem.
Yeah.
Just wait for 2 minutes.
Yes, sir.
So is it visible now?
Yes, sir.
So the application of HRI system is in the healthcare, where the robot assists in a surgery, elder care, and rehabilitation. Then also in educations, where the social robots helps children to learn and helps children to learn through interactive sessions or interactive play like a games or solving a puzzle and make the children's friendly with the robots. Then the application is in industry where the cobots are used on the factory floor. Then space exploration, robots like NASA's Robonaut supports astronaut in the orbit or make exploration on the Mars where the human is not able to go there and search for the other things. Challenges in HRI is a trust and acceptance. People may hesitate to rely on the robots because it's after all it's a machine which is not trustworthy in the current stage. Then emotional intelligence, as a robot still struggles to interpret the complex human emotions. As a robot don't have the any kind of emotions. They are the machines who works as per the command. Then safety and ethics of the this HRI, ensuring don't harm or manipulate users critically. This is the human robot interactions. Then emotional intelligence in robots. Emotional intelligence in robots, often referred as a emotional AI, which is also called as a EI, or affective computing, is one of the most exciting frontiers in the human robot interaction. While robots don't feel emotions themselves, so they can be designed to recognize or interpret or respond to the human emotions in the way that feels empathy and social awareness, which is giving the emotion to the current robots. How AI works? It works on the facial recognition. Like there is a high definition camera situated in the robots. Generally, this kind of the emotions we are able to see in the humanoid robots. These are not related to the industrial robots or the working robots or all. So they recognize the facial expressions. Is the man is angry or he is happy or how he is behaving. So analyzing them, uh, that's the one kind of the AI works. Then voice analysis means how man is talking to the robot. Yeah, you can see there is a many company hire the bots or generated the bots for their calling preferences. So when you call the customer care, they have a voice analysis that uh, gives the customer representative feedback that that man is angry or he is happy or he wants help or all these things. Then natural language processing means how the man is behaving, how is the body language, how is performing any task. In the China office, you can see the video is available on the YouTube. They fitted the camera and they connected to their computers where the employee is working. They predict the time and how he is working. He is doing a time pass or something. Hmm. That cameras are fitted in the China's office. Those works on the natural language processing. Then the behavior tracking, as we already discussed about this, how man is behaving, how he is expressing his thoughts by their body language and all. The application of AI, the basic application is in the healthcare. Robot detects the patient discomfort, sadness, or caregiver alert the caregiver, or often soothing the interaction. In the education, emotionally aware robots adjust the teaching methods based on the students' engagement and confusion. Then, as I already told you, customer service bot can decelerate the tense situation by recognizing the frustration and responsibility calmly. Elder care, companion robots offer emotional support and monitor the mental well-being. Challenges in AI. There is a challenge first is about the accuracy. How we predicting the emotion of the human nature. If he missplit the emotion, then the result will be different. The accuracy, the emotional complex and culturally, nouns robot can misprint the signals. Then privacy. Emotional data is a sensitive, ethical handling is essential. Means sometimes if you had the Siri as iPhone's AI representative or the Google's Gemini, we shared the pictures though and to change there into some kind of a trend. But as per the policy, we don't know that this picture going to be shared or leak anywhere. That's kind of the privacy required in this emotional data because the highly qualified mentalists they can use that data for their misleading jobs. Then the sorry, there's the trust. User may feel uneasy if robots are seen too human or manipulative. Then, what challenges do interface robots face today? The interface robots facing the mixed technical, social, ethical challenges as they become the more integrated into our daily lives. Here, a breakdown for your presentation. First are the technical challenges, natural human interaction. Robot still struggles to interpret the human emotions, sarcasm, gestures, and tone accuracy. They makes truly intuitive communication difficult. Second, sensing and precision. Despite advantages in the sensors like lidar, cameras, then robot often misinterpret the complex environments or fail in the low light, noisy environment or in a clustered setting. Then motion control, achieving a smooth, precise, and safe movement, especially in the unpredictable environment, is a major hurdle for the robots to interface with the human. Then energy efficiency. Many robots rely on the bulky batteries that limits the mobility and require the frequent recharging. Long-term power supply solution is still evolving in this kind of the. Then ethical and social challenges, privacy concern. Interface robots often collect the data during the interaction, raise the question about the consent and data protection. This kind of the data is used by their AI, and the AI gives the solution. So they have to search it on the internet or their company's base server. Whatever the data we are giving to the robot is goes to the company's server. So hence there is a privacy concern. Then job displacement. As robot become more capable, they are growing concern about their impact on the employment in a various sectors. Uh, as we know, the complete sheet metal sector of the car manufacturing industry is rely on these robots right now. Then bias in AI. If not correctly designed, robot can inherit and amplify biases present in their training data. These are the social and ethical challenges. Then AI and learning limitation. Adaptive intelligence. Robots need to learn and make the decision in a real time, but current AI system often lacks the flexibility and contextual understanding. Humans takes as a granted. They takes human as a granted because the AI is still developing and there is a too many complications while programming in AI. Also, they require the internet connection continuously. If there is any kind of lag in internet connections, the AI won't work. Then autonomy versus control. Balancing autonomous decision making with the human oversight is tricky, especially its high stakes environment like healthcare or defense. The robot cannot automate in some sectors where it crucial to humans' life. That's why they have a challenge in their learning. Then human robot interactions, as we already discussed about the trust, people may feel uneasy or distrustful to the robot, especially if they behave unpredictably or lack of emotional intelligence. Accessibility, high cost and complex interface can make a robot inaccessible to small organization or individual. Because if you want to take a robot for high manufacturing, it having a huge cost, and that cost relies uh, means most of the value of the investment for a single job. That's why the accessibility of the robot is not, it's a big challenge in today's field. Then the real world example I can share you. Self-driving car, essentially mobile interface robot, still struggles with the bad behavior, with the bad weather, unpredictable human behavior, and ethical decision making in the emergency. Minor, these challenges mirror the border issues in robotics. If you saw the news, one Tesla car is impacted over the barricade, and after the investigation, they found that the autopilot, their autopilot interface, is completely dead while driving a car. That's why the automatic vehicles are not still reliable. Then we move to our next session, means half session, which is the programmable logical control. Means we are discussing here the programmable logical control interface. First, we have to understand, as we had a last session about the PLC. This is here you can we learn the history about the PLC in the last session. I am just taking a basic coverage here. The PLC is a programmable logic controller, is like a brain behind the industrial automation. It's a rugged, specially computer designed to control the machinery and processes in the environment that often has to regulate the regular computers. The things factories like a power plant, water treatment plant, even in our factory, we use as a PLCs widely as a as in a pin punching machine, and then making a bending machine. We use as a PLC, and also in a sheet metal bending machine, sheet metal cutting machine, like that. You can see there are the two types of PLC. One is a analog, means one is a with the serial data communication, and another is a new one which is a LAN communicated over the LAN. The simple thing is PLC works on the clock. The system contains the clock. Here you can see. I'm just starting the laser pointer. Here you can see there is a battery. Also in this there is a battery. That battery helps to monitor the clock, as our PC requires the cell for separate on the motherboard for CMOS functioning. Same, this PLC requires a battery. The above part is a input function, and the below are the output functions for the output connections. This you can see in this PLC, there is a 24 volt DC in inward supply, and C0 to C0, 1, 2, 3. These are the input signal data for the input signal data, and C1 for the another signal data. Also there is C2 to C3. These are the output actuators data. What makes a PLC special? First is the durability. Operates reliability in the extreme condition, heat, dust, vibration. Real-time control instantly responds to the inputs from the sensor and switches. Programmable, engineers can write custom logics to control the complex system. Modular design, easy to expand with the inputs and output models. How it works, it inputs the sensor and switches sends a signal to PLC. There are two kinds of the signals. One is a digital signal and one is an analog signal. In both cases, the digital signal and analog signal is converted into digital signal in PLC. And as per the requirement, the digital or analog signal is goes uh, goes to the actuators as per the actuators requirement. So these signals are from the sensors. Actually, the sensors may create two types of the variation. First is a resistive variation, and second is a potential variation. We can see in the inputs uh, accessories there. So we will discuss there. Then the processing. The PLC runs on the programmable instructions, which is a logic. Then output, based on the logic, it sends the command to the actuators, motors, lights, etc. Whatever the actuators is there. Common use in the manufacturing, assembly lines, robotics, conveyors. Then automotive, it's uses for the quality control, engine testing, and other. Building the automation like HVAC, what the field I am working in. Then lighting, system securities, utilization in water treatment or power distribution. Then this is the basic architecture of PLC. So there are the two bus. One is the PLC bus, and there is a second is a input output bus. So you can see there is a power supply. This is the controlling unit. There is a memory. Memory backup is required to store the program. This is the input and output controller. Here the input signals comes. There is a buffer which clear the noises and all. Then the programming panel where the programmer can program the PLC. Then also there is a communication field bus connection to locate the network processor. So from here also you can access all these points via remote channel, and these are the physical channel. But what I show you already with the serial communication and LAN communication. Then the output goes to the interface, device interface, sorry, driver interface, and drivers gives the signal to the output channel. This is the basic schematic diagram of the PLC. Then in the next slide, these are the three types of the PLC. First is the fixed. We are going to see this example. I'm going to show you some video about our product. Then the distributed. I'm also going to show you the distributed PLCs. And the third is the modular. These are the fixed with the this is the fixed PLC, which having an input bus, input interface on the top, CPU, memory, and power supply here, communication interface for the programming and giving the signals and giving the output here, which connects here, and this is the output interface. This is the fixed PLC with the limited number of the input signal and with the limited number of the output signal. That's why it's called a fixed PLC. Second is the modular PLC. In modular PLC, the five modules are you can get by using a PLC. Whenever you require, you can add the input and output module here. So that module it would be maximized, or you can attach and detach as per your requirement. First, you can see there is a power supply, then there is a control unit, then there is a communication port, another communication port, and there is a input and output interface. As per the if the sensors are increased, or if you want to increase the actuators, you can add these input output interface or remove as per the requirement. Then the third is the distributed PLC. Here you can see the PLC input output here. Those are connected with the LAN or wireless network with the remote input and output. Means you can place PLC at the one place, the input output module at the another place, then the second PLC for the communication with the first PLC at another place. Also add the remote PLC input output at the one place. These are the three kind of the PLC. There is a difference between these three. The fixed PLC having a low CPU performance, the modular having a high, medium to high, and the distributed PLC is having a high performance. Then the program and data memory size. This fixed PLC having a small, modular PLC having a medium to large, and distributed PLC has a large memory size. Power supply is embedded means between. Then for the modular and distributed, you have to buy the power supply separately, or you have to attach the power supply separately. Input output and communication interface are embedded in the PLC. In modular PLC, you have to attach, and in the distributed PLC, you have to attach the communication as well as input and output interface. Then the mounting system. This is a single unit. You can mount wherever you want. Then for the modular PC, modular PLC. You have to you require the rack, back panel, rail, or chassis. Physical size of the PLC. This is small. This is the medium to large, and this is the medium to large. Flexibility. This don't have the flexibility. Modular and distributed PLC have the flexibility. Customizability, fixed PLC don't have the customizability. Modular and distributed PLC have the applications. According to the application, fixed PLC used for the basic application with the small number of inputs and outputs. Medium PLC uses the high-end for the high-end application, large number of inputs and outputs. With the same, this distributed PLC uses where the very large number of the inputs and outputs. Fixed PLC cost less than modular PLC having a medium cost, distributed PLC having a high cost. These are the some kind of the programmable language which are the for use for the PLC. One is a structured text. You have to write the complete program according to the PLC behave. Then you can see here is a ladder diagram. This is the ladder diagram for the PLC where you give the signal to the every rungs and which communicates accordingly. And you can see here this is the logic expressions and tags where the input given in a binary form. This is the false position. This is the true position. And these are the actual signals given to the actuators. Then sequential function block. Here the first condition completed, then the second conditions works in action, then third condition, then the third conditions, then it gives the action third, and the fourth condition gives the action fourth. Then again it goes back to the first condition. Means this is the sequential or the loop form. Then a functional block diagram. This kind of the programming useful for the measuring the temperature and the humidity and all, or the gas levels, hazardous gas levels in any kind of a storage. Here you can see there is a maximum minimum value with the unit. This is the address bar. This is the address of that registers, and these are the values. So, and this in the second you can see there is the humidity which is goes 0 to 100, and here the unit is Celsius, means there is a temperature. This input module measures the temperature in the Celsius, and they do the task of the sequence in the writing here. Then the last kind of the programmable language is instruction list. So you can see there is a set on S0, then start on the S0, set on a S20, as these program is written in the instruction list. These all five are the PLC's programming, which depends on the manufacturer of the PLC, which what they are using and all. Then you can see there are the plenty of input devices are there. So I'm going to explain you each. Here you can see there are the laser signal receiver. There is a one is the input and there is a one is the output. We uses this kind of the signal in a sorry where the in a bending machine where if the any human hand is stuck in the bending machine, this these signals don't allow PLC to perform the bending operation. That won't allow to harm the human hand. This kind of the signals detects is a digital signal, which is the true or false, where these signals sent to the PLC. Then you can see there is a HMI screen, which is useful for the programming as well as controlling the PLC. This is the float switch. Here you can see there are the three wires, one for the input, one for the output, and one for the signal. As this float wall goes down, there are the two lines which connects to the each other. When the float switch goes up, the contact due to the ball metallic ball inside this is breaks, and this gives the false signal. So the pump, generally this one is used in the tank, then the pump shuts off, so the tank is not going to be overflow. This is the limit switch you can see here, which also signals true or false by using a touch sensor moment after the movement of the this roller. This is the flow sensor. Flow sensors gives the electric pulse as a signal with the small EMF. The electrical pulse generated by the turbine inside this box. At the one end, you attach the inlet of the flow, and at the second end, you attach the outlet of the flow. Then these are the thermocouples, which is used for to sense the temperature. That thermocouples use the bimetallic strip. As the temperature changes, the resistance of this signal is changes, which gives the input to the PLC. Then the push button are there to start and stop the process. Then these are the angle sensor, what we use in the different kind of the bending operations, which predicts the angle and allows PLC to stop by using this data. And then this is the Hall sensor, which works on the change in the magnetic fields. As the magnetic field changes, it gives the resistance to the as a signal. This is the pressure sensors. It actually works on the definite area. Inside this, there is a load cell. As the pressure changes, the load cell changes its resistance, and that resistance works as a analog signal to the PLC. This is the proximity sensor, which uses to sense the presence or sense or presence any kind of the product in front of them without touching that product. This is also digital signal processor, means device. This is the CT coil. CT coil is the current transformer, which is useful to measure the current without cutting or without attaching the wire. The field wire. We require to just swap this. We just require to lock the wire through this hole, and without any kind of the communication, any kind of the touch or cutting of the wire, this wire use the current rating by generating the magnetic field here. This gives the current rating, how much current is flowing through the wire. This is crucial and required in some cases, which I am going to show you. Then another are the output devices. As there is a input devices to the PLC, there are the output devices also. This is the solenoid valve you can see here, which actuates once the flow sensor or the whenever the required or not required, we have to start and stop the flow electronically. This is the solenoid valve attached to the body. Then whenever required, you can flow from one side and use outlet to the other side. Then this is the relay, which electronically triggers the switch to start and stop the machines. These are the light indicators, which also works as a process quality and all. This is the VFD, which uses to control the motor speed and motor voltage. These tools are the servo motor and stepper motor, which works by using a PLC. Then these are the lamp indicator, how the process is working. Then this is the contactor relay, which starts and stops with the signal, which is generally used in a high voltage motors to start the motors or stop the motors. There are some limitations of PLC. As a limited power processing power, PLC are optimized for the control task for not for the complex data processing or high speed computing. PLC is useful just for the simple sequential operations or multiple sequential operations. They may struggles with the large scale data analytics or advantageous algorithm perform to the system like DCS, distributed system control. Then limited expandability. Some PLC, especially compact models, have fixed input and output and limited room for the expansion. Scaling up may require for the replacing. mm, For scaling up, we may require the and replace the entire unit or by adding a modules. Then cost consideration. While generally the cost effective PLC, high-end PLC and their accessories like a programming software and specialized modules can be expensive to purchase and maintain. Programming complexity. PLC require the knowledge of a specific programming language, ladder, structure text and all. This can be a barrier for the new users and may require the specialized training. Vendor lock-in. Software and hardware from the one manufacturer often aren't compatible with the other. This limits the flexibility and can increase the long-term cost. Power recovery risk. After a power uh, outage, the PLC may restart automatically, which can cause the uninterrupted operation unless fail-safe programming in the place. So these are the PLC's program. I'm going to show you the our site pictures. Is it visible to everyone?
Yes, sir, it's
Yes, sir.
visible.
Yes, sir. It's visible, sir.
So, I'm going to show you what we are doing and this is the current industrial example. This is the individual quick freezer. You can see there is a line coming from blue color line here. This is the use. This machine is used to freeze the green peas within a 9 minutes. This machine is able to freeze a 1 ton capacity, 1 ton green peas in a 1 hour. So we uses the PLC programming, and you can see there is a panel, electrical panel. I'm going to show you in the next. This is the programmable PLC panel. This is the input of the green peas here, and on the other side there is a output of the green peas. Then I'm going to show you the front picture. You can see there is a fan here, and the coil is here, which is used for the as a heat exchange. This is the PLC. You can see here the HMI screen. And sorry for the we are not able to see what behind this. There is a here there are the mainly 6 VFDs which control this fan speed as well as the belt speed. I'm going to show you the video. You can see there is a contactor, what I showed you, to start and stop the motor. Here you can see the relays here, and these are the PLC modules which helps this HMI screen to perform. Okay, is it I think slightly visible here? These are the relays, and these are the connections provided to the sensors for the this set is the input sensors, and at the other side there is output for the actuators. Then I'm going to show you some videos of that. This is the inside of the machine. This is the individual quick freezer. This pins cools the air inside this box up to the minus 40 degrees Celsius within a 10 minutes. So due to that drastically change, the frosting is generated on this pin, and as we all know, the frost is a works as an insulator or the bad conductor of the heat. So the air is not going to be get cooled if we don't remove the frost. Then these yellow lines works as a air lines, and these shapes I'm going to show you. Here you can see these shapes used as a nozzles. You can see there is a nozzles. This is the freeze belt. This is the load belt where the air is going to freeze the green peas. There are the angle sensors. I'm going to stop. Okay. Are you able to see my cursor? Hello?
Yes, sir. Yes, sir.
This mechanism allows the 6-bar pressured air to through the nozzles to clean the frost. You are going to see the video. Right now there is no frost because I am not here. No one can allow it inside when it's a minus 40 degrees Celsius. So this chamber forces air towards the fin so that the frost is going to be removed by that pressure. You can see here is a small these are the proximity sensors, and this mechanism is travelable. It slowly travels from that side of the fin, means we call it as a bend side and the header side. Here header sides means from the sides where the refrigerant comes in the coils, from header side to the bend side, and these are the works as a stopper. You can see the big plate here written that Nasik on it. When it comes in front of this sensor, the PLC changes the direction of that screw. Here you can see the screw here. PLC changes the direction of the screw here. And this is the emergency stop. If this panel hits that this plate, all the mechanism is going to stop. Uh, Here is the lead screw which attached to the gearbox there, which changes the direction, and all these three headers going to change their direction and again do the frosting method. I'm going to sound. Are you able to listen the sound?
No, sir.
And then I have to change something.
While sharing, please try to enable the audio sharing, sound sharing.
Okay. Just wait, I'm going to show you another video. Sorry, I don't found any kind of the option. So I'm just showing you the video. This is the outside, and this PLC controls the four motors of the fan having a capacity of 15 HP each. Then the doors, heaters, because at the minus 40 degrees Celsius, this door going to be locked. Hence, there is a provision for the heating the door here. You can see the front side of that unit. Here you can see the emergency switch. Once I hit that switch, the PLC is going to stop each and everything. This is also called as a lifeline switch. You can see here it's a air temperature sensor attached here. Also, PLC controls the each motors with VFD, and these motors are work in a minus 40 degrees Celsius environment. Mm, That's why they have an anti-condensation heater in it, which allows to remove the frost from the winding. You can see the, I'm going to show you the inside first. This is the refrigerant inlet. You can see here in the black. The small one is the inlet and the bigger pipe is the outlet, which is the gas outlet and the liquid inlet. This is the third door where you can access the fan. Sorry, I am not able to. You can see the fan having a two wires here. You can see one for the anti-condensation heater, then the RPM sensors of that fan, and power supply of that fan. This is the load belt. There is a there. This is the gearbox for the freeze belt. This is the, again same safety switch. These are the fluidizer motors. This is the complete construction of IQF. Then are you able to receive any kind of audio? Because this machine is working right now. You can see the movement of this pipe. This allows 6 bar pressure, and it directly throw from the nozzles to remove the frost. This is the fluidization action where the excess moisture of the green peas is removed. This is the stirrer. This belts is running right now, but they are too slow. You can see through the fins. There is a injection of the air. One by one, these nozzles, there are three nozzles. First, it inject the air from the first nozzle, then second nozzle, then third nozzle, then again goes to the first nozzle. This sequence is controlled by the solenoid, and those solenoids are controlled by the PLC. Here you can see the small screw. Sorry. Here, this screw allows these three move parallelly from this side of the fin to the that side of the fin, and making a motion, means a linear motion. Once it's connected to the it goes on that proximity sensor. This motor's direction is reversed. Then this is the last video. You can see the stream of water is coming from here. That's due to that motion. Sorry, that air release from the that nozzles. Also, when this system is off and there is a frost on this, you can see the pipeline here, which allows the water to rinse this frosting and wash these fins using the water. That water also comes with the flow solenoid. I had some examples of PLC controlling. I'm going to show you. Right now, this is the login to the PLC. I'm doing a remotely login to the PLC. Okay. This PLC works as a measurer, or this PLC used to measure the working efficiency of the plant. You can see there are some sensors attached here. You can see sensor types. These are the sensors: pressure sensors, temperature sensors, then some another sensors, and these are the address of the sensors. Have you saw that address? What we are told about? These are the address on the PLC. There are the multiple sensors. You can see here SME, SME2, same sensor master. You can see here float sensors and all, temperature sensors. So this data you can see here. This is the quality and operational efficiency. To find this dashboard is useful for the operational efficiency finder. This gives the machine efficiency, hourly OE. That's what we called in a reason for the delay in the downtime. Sorry, why the downtime is there, why the production loss is there. Then then there is a sector dashboard. This is the online. That's why it takes a time. You can see this is the production line. And this is the wire injection molding, which manufactures the insulated copper wire. So this monitoring PLC shows that this R1 is this is the rejection code 1. Why this piece is rejected, giving the highest value means, and accordingly the dashboard shows that these rejection are happening there with the different code, and they registered as per their time. So in which kind of the rejection we are losing our precious product, that we are able to get from here. Then quality dashboard, you can see here. How much product is manufactured, how much is rejected, how much the rejection rate, how much the rejection in parts per million, which machine is performing best, where the registration, where the rejection is there, and all. I am not taking time because I think we are losing time. So I think that's it from my side. Thank you. Anyone having any questions?
Okay. So, dear participants, curiosity is the spark that turns knowledge into wisdom. So, then don't let your questions rest in silence. Share them and let this dialogue become a memorable exchange of idea. So, I humbly request all the participants, those who are having any queries, may ask and have an interaction with the expert. Ask the doubts about the technological aspects that shared over here.
Hello, sir.
Hello?
Hi, sir. My question is that within 10 minutes, the temperature of that box is going to decrease up to minus 40 degrees Celsius. So,
Yes,
which
sir.
refrigerant used there?
So we uses the ammonia refrigerant there, which is
Ammonia.
widely used in means minus operations. We generally use the R403 also, or R04 also. But as per the availability with the customer, we uses the refrigerant because
Sir, there
the
is
easily available, and it's very cheaper. We design the coil according to the requirement and the heat load, sir. If you require the coil for the, I think 20 kilowatt for the freezing of that in a half hour. I'm just giving you example. We design the coil with a capacity of 200 kilowatt.
okay. Thank you, sir. Thank you.
Mm.
Any other participant? So it seems that all the concepts that you have been shared over here are well understood by the audience. So as no queries from their end.
Okay, sir. Then I would like to thank uh, the convener and the patron of this faculty development program, Dr. Yadav sir, principal of SND Yola. Also like to thank Dr. Harjit Pawar sir, the coordinator of this FDP event. Then also like to thank Dr. Rachel Rane, who is a co-coordinator of this event, and also thank all the participants and Jagdamba Education Society for giving me opportunity to share my knowledge with you people.
Okay, sir. So good evening, everyone. So today's session with by Dr. Avinash Bagul sir has been very interactive. He talked about the robotics and PLCs. So it felt like a glimpse into the future of technology itself. So the way you guided us through the through the interface between the robots and PLCs that showed us that the connection is not merely the technical, but a truly the nerve center of the modern automation. So without it, the harmony of machine, data, and decision that's making would not be exist. So what made this session special was the balance between the depth and vision. So you walked us through the type of interfaces, giving us the giving us the clear understanding of how diverse these systems and how they serve unique role in the industrial sector. At the same time, the explanation of core technologies that reveal the invisible intelligence that allows the machines to sense and think and act with the precision. But the what really captured our imagination was when you spoke about the human robot interaction. You reminded that the purpose of technology is not to replace the humans but to work with them. So complementing human skills, extending the human ability, and creating the safer and smarter workspace. And then when you introduce the idea of emotion intelligence in the robot, it felt as if you transport us into the tomorrow's world where machines are not only the efficient but also empathetic, where they understand our needs, responds with the sensitivity, and maybe even connect with us on human level. So that thought was both fascinating and inspiring. So, sir, what we taking back from this session is not only the technical knowledge but also a sense of wonder. So you made us realize that being an engineer in today's world means being part of a story where machines and humans grow together, shaping the industries for tomorrow. So, on behalf of all of us, we thank you, sir, for giving us your time, for sharing your knowledge, and generously, and for opening the mind of new possibilities. So, this session will remain with us as a reminder of how exciting the future can be when we blend imagination with technology. So, thank you so much. Thank you very much, sir.
Thank you, sir.
Yeah. So, dear participants, it's a heartfelt thank you to each one of you for joining today's session and making it meaningful with your presence. So, we'll continue this journey of learning with more insightful sessions tomorrow. Until then, I encourage you to stay curious, remain passionate, carry forward the spark of inquiry that fuel that truly grow. So let's come back with the same energy and enthusiasm to explore even deeper. So I look forward to meet you tomorrow with the same zeal, excitement, and enthusiasm. Until then, thank you once again and have a pleasant evening and very good night. Thank you so much. The feedback link will be shared in the chat box. So please fill it, respond it. Thank you.